welcome to another video clip of MrLopezClasses.com. Today we are going to continue in our class of marine gasoline engines. In this particular laboratory, we are going to analyze the sensors and the codes related with the sensors. Yes, the idea in my classes of gasoline and diesel is that you understand the engine. You understand the engines, the fundamentals of the engines. And if you understand the engine, if you know how is the refrigeration system, how is the cooling system, how is the ignition system, the fuel system, it's easy diagnosis the engines by phone. Because if you ask a couple of questions to the customer, you can identify where is the problem and how to solve those problems. In other words, I want that you try to solve electrical, electronic, and mechanical problems without the scanner. Yes, in some cases the scanner is necessary because you need to clean the codes. But I need that you identify with your acknowledge where is the problem. For what reason I have the check engine light on. Okay, you can use the scanner of that particular engine to identify specifically what is the code. What is the code that is producing the alarm. Okay, I have the code, the OBD2 code, and with that code, I am going to identify if the problem is the sensor, or if the problem is the sender, yeah, or if the problem is the gauge, or if the problem is the computer. But if you have clear the concepts and you understand the engine, it's easy to identify where is the problem. I created some years ago this wonderful table. That table in order to follow OBD2 codes for gasoline and diesel engines. In both classes, in the classes of gas and diesel, we are going to use that wonderful table to identify the codes, to identify the cause for that code, the consequence, the symptoms, and how to clean, how to eliminate those codes in the dashboard of your boat. In this particular laboratory, I hope that with your instructor, you play a little with some sensors in order to understand how the sensors operate. For example, I want that you try to play with the throttle position sensor. Yeah, the throttle position sensor located in the throttle body of your engine. Okay, identify where is located the throttle position sensor. Remember that the throttle position sensor can be checked with the engine running or with the engine stop. With the engine running, it's important to identify in the throttle position sensor. Normally, those sensors have 3 cables. One is the ground, the other one is the positive coming from the computer, and the other one is the signal. Alright, it's important that you identify what is the ground, what is the positive coming from the computer, and what is the signal. Okay, and with a couple of needles, introduce the needle, punch the cable with a couple of needles, and connect alligators connected to your voltmeter. And with the engine running, accelerate the engine and verify the voltage. The voltage normally fluctuates in between 0.7 volts until 4.7 maximum 5 volts, depending on the angle of acceleration in the flap of the throttle body, in the butterfly. Yes, I want that you check what happened in idle, how much is the voltage, and what happened in wide open throttle, and try to verify if those readings are in the range authorized for the manufacture of that particular engine. But in general, you don't need the manual. Okay, the voltage is going from 1.0 or 0.7 And I accelerate and go more, 3.7, 4.2, 4.7, 4.8. Okay, the throttle position sensor is working good. Okay, suppose that the engine is off. Punch the ground and the signal and connect your voltmeter in DC with the alligator terminals over there and check the resistance. Okay, less resistance in idle, more resistance in wide open throttle. If when you move the flap, the resistance change from 200 ohms until 1.2 kilo ohms, depend of the manufacturer. If the resistance change, it's because the throttle position sensor is in good condition. Okay, this is one sensor, the throttle position sensor. We can play with other sensors. There are a lot of sensors in the harness of your engine. But for example, we are going to check the coolant temperature sensor. We can play with the coolant temperature sensor easily. You can remove the coolant temperature sensor from the thermostat housing. Remove the coolant temperature sensor and check in the terminals. If the coolant temperature sensor uses only one terminal, that terminal is the signal. The body of the sensor is the ground. Or if the coolant temperature sensor have two terminals, one is ground and the other one is signal. Doesn't matter because it's a coil. If the coolant temperature sensor have three terminals, one is ground, the other one is positive coming from the ignition switch, and the other one is the signal. Alright? Okay, normally the coolant temperature sensors are one terminals or two terminals. Alright. You can connect one alligator cable to the body of the coolant temperature sensor to the negative of the battery, and other one to the terminal, the output terminal of the sensor. Yeah, and you select your multimeter. You select your multimeter in ohms, and now you put the heat gun or the lighter, the flame over there, and the temperature increase, and verify what happened with the resistance decrease. And you remove the flame, you blow, and the resistance decrease. This is an indication that the coolant temperature sensor is working properly. Yeah. This is when you remove the coolant temperature sensor and you check outside. Or if the coolant temperature sensor is located on the thermostat housing, you can start the engine and verify with the engine running what happened with the resistance, with the engine low RPMs, and after that 10 minutes later what happened with the resistance, and verify that reading according with the manufacturer, with the standard recommended by the manufacturer. This is with the coolant temperature sensor. We can play a little with the crank position sensor, and for example, we can disconnect the crank position sensor, and now try to start. The engine no start because we don't have signal reading the timing. Okay, and after that connect again and start the engine, and the engine start immediately. This is a simple way to identify if the crank position sensor is working. With the cam position sensor is exactly the same. You start the engine starts properly, you stop, you disconnect the plug on the cam position sensor, and you try to start the engine no start. Because crank position sensor and cam position sensor, they work together and they send indication to the computer in order to start the engine. This is wonderful. It's easy to identify what happened with those particular sensors. Other sensor is the exhaust gas temperature sensor, located at the elbow of the exhaust manifold. With that sensor, you can verify what happens if you close the raw water, the flow of raw water. Immediately the temperature of the gases increase and the engine shut down for high temperature. This is an indication. This is an indication that the exhaust gas temperature sensor is working. You open again the valve, the raw water valve, and the engine starts immediately, and the engine continues running properly because the temperature of the exhaust gases is the temperature recommended for the manufacturer. Yes, I want that you play with your instructors, connecting and disconnecting sensors and checking what happened, what is the performance. I recommend follow this poster. Yes, you find those posters in my webpage. You can buy those posters. I recommend that poster in particular, the poster related with the sensors. You can play with each sensor. You can read the sensors and you can identify where is the problem. Let me explain something. All the sensors have the same behavior. They work in similar way. Doesn't matter if the engine is gasoline or diesel, they have the same function. The NOx sensor in gas and diesel work exactly the same. The throttle position sensor exactly the same. The oil pressure sensor exactly. All the sensors work in similar way. In other words, if I have the manual of your car, you have a Honda Civic, and you have the manual of your car, and you want to know if my throttle position sensor in my boat, in my Mer Cruiser is good or not, and you have the manual of the Honda, check what happened with the throttle position sensor. How is the procedure? How is the procedure to troubleshoot that sensor? And that procedure applies exactly for your Mer Cruiser. Probably the values are different because Mer Cruiser use different values, but the procedure is the same. The procedure to check the oxygen sensor is exactly the same. The procedure to check a problem related with the NOx sensor is exactly the same. Doesn't matter the model, if it's a gas or diesel, the sensor work in the same way. If you have a manual of any type of engine, the procedure to do the troubleshoot on the sensor is the same. The procedure, the values probably are different according with each manufacturer, but the procedure is the same. In other words, you don't need, oh, I don't have the scanner, I don't have, you have another manual, okay, and you have the acknowledge, you can do the diagnosis. I hope that you practice in this lab with your instructor. Practice, practice, practice. Disconnecting. Ask to him, hey, what happened with the coolant temperature sensor? What happened with the IAC sensor? The IAC sensor that I explained in a wonderful video. You remember that video? Okay, the next step is check the IAC.
Yeah, and then after that we'll do the IAC.
Alright. Okay, we are going to remove the IAC in order to verify the condition. Oh, Danny, look at this. Alright, yeah. What is the solution?
Well, what we're going to do now is Robert is going to get some power tune, and we're going to spray power tune and clean it, and then we're going to retest it.
Yes, we identified one problem in a Suzuki 250 outboard with the IAC. Ask to him again what happened with that particular sensor. How is the procedure to identify a problem related with the IAC and with other sensors. In this particular lab, we are going to play with sensors.
Idle's good, then we resolve the IAC problem. Still, right. Even though we cleaned it, we seen there was a lot of carbon deposit, but we don't know for sure if there's still a problem mechanically movement.
Correct.
But this is the only way to know. You have to do a process of elimination. We investigated, we visually inspected it, and we realized that it was carboned up, so we cleaned it. Now we're going to do the testing.
Okay, if not, we investigate in other place.
Another place, correct.
Other way to identify problems related with the sensors is the process of elimination. And we are going to check today that particular example with Danny, the expert in Evinrude in a real locomarine. We are going to ask to Danny, what is the complaint of the customer?
He's complaining when he goes into his joystick steering that he's getting a code and it locks him out and he has no steering at that point.
Oh, yeah. And you are suspicious about what?
It's either going to be a chafed harness or a bad solenoid valve.
Oh,
Directional valve.
yeah. And now I think that you start with the process of elimination. Okay, this is the complaint of the customer. After that, Danny disassemble the engine, remove all the plastic in order to start to check. The first step is check the quality, the integrity of the harness. What is the first step?
First step, we're going to go through and just check to make sure that there's no chafed harnesses anywhere, because we can go through and dry test everything with the laptop and it's all functional.
Okay.
So we're going to go through and see maybe with them running it if there's a vibration and a wire that started to chafe on the block, short. We're going to go that route first and see what's going on. In the meantime, I've actually got BRP on the phone right now.
Yeah, correct. Okay, after that, Danny connect the computer, the scanner, and he identify some errors, some code. How many errors? How many codes, Danny?
In different modules.
You connect the scanner, and you found 7 reports.
I downloaded all 7 reports. You've got an engine report for each engine. You've got a control box report.
Correct.
You've got what they call a surface mode controller.
Okay.
Which is what controls the joystick. You've got, so there's 2 of those, then there's a pressure sensor module, plus the joystick assembly.
Oh, okay. Okay, perfect. Okay. And now, Danny start to check cable by cable, sensor by sensor, if the cables are in good conditions, no crack, no bended, no burn, because in outboards all the cables are together enclosed and pretty close to the block of the engine. In this particular case, that was the process, cable by cable. It's a long process. In this particular case, more than 2 hours. Danny is checking for the condition of the harness, verifying this is the ground, the wires loose in good conditions, the connection is tight. What cable is that?
This is what controls these sensors.
Oh, okay. A lot. Okay, and now he called the help desk of Evinrude, and the help desk of Evinrude said that he needs verify, according with the manual, the value of the reading in ohms in some particular relays, and those are the values and the readings for those particular relays. After Danny spoke with the people of Evinrude, they recommend something, Danny?
They just wanted me to do an ohms test to see if I got a short to ground.
Check ohms, check resistance on the harness.
On the solenoids.
On the solenoid, okay.
Yeah,
Which
13 ohms.
solenoid?
The directional ones for the steering system.
Oh, okay. 7.8 ohms
It's low.
in between
It's 10.6. Alright, so
and the reading should be 9.8
plus or minus 5.
plus minus 5.
But is it 5 volts or is it 0.5 of a volt? They didn't know.
Okay.
Alright,
The
so
black
it's
yellow
10.7.
to the black, the reading should be in
10.6
between
and
9.8 11.4 Okay, we found it that those readings are according with the manual.
So my question is it says that it's supposed to be 9.8 plus or minus 5 ohms. We're
Right.
doing an ohms reading.
Right.
Is that 5.0 difference or 0.5 difference?
No, 5 ohms of difference.
So this can go as anywhere from
Is
4.8 to
to
14.8?
14.8, correct.
So how the hell
This
does
is
that
correct.
give you? I mean, it gives you such a broad window.
Yeah, but this is
And
the
what-
window.
In the other one, you got only 7.8.
7.8. So they're both within spec.
Both are correct.
In other words, the sensors are okay, the readings are okay, the harness is in good condition. The problem is the model.
So it
So
needs
then
a-
it's
it
gonna
needs
be
a
module.
This is the model. That's correct.
needs a module.
Well, change the model
Alright.
and see what happens.
We are going to change the
So-
model. We can switch the model.
I don't. It's not worth it. It's too much work to get to the module. And I think the program for
You
each
can't
motor,
switch them.
No.
right?
No.
The program for each motor.
Yes.
Oh, okay.
Right, so
There's a counter and there's a starboard or a
Oh,
standard and
because it's
port.
different.
Remember, this is
Because
an
these are
iDock
joystick.
system.
Yeah, yeah.
Joystick system.
Correct. Correct. Okay. In that
Tell you
case,
you're gonna order.
order the model.
You still have time.
Yes, in this particular case, the solution is replace the model because the sensors are good, the sender is in good condition, this is the harness, the sensors, the sender, the relays are in great conditions, the source of power is good, the ground is good. The only possibility, according with the help decks, according with the manual, is replace the model. They order the model, they replace the model, and the engine starts perfect.